We're now working on this challenge, which is called Neat RSA, and it says RSA is pretty neat, especially when a source is provided. So how about let's take a look at the source. So taking a look at the source, we see that it opens the flag file and then it reads it, and then it generates 3 primes, and then n1 will be equals to p times q, and n2 will be equals to q times r, and e will be 65537, and elusive is just a 4-digit number, and then the CT will be the plain text to the power of e modulus n1, and then it will open the rsa.txt, and then it will write the values of n1, n2 plus n1 times elusive and CT, and we can also infer on the fact that n2 plus n1 times elusive is the same as just elusive times p plus r times q. So n2 plus n1 times elusive is the same thing as elusive times p plus r times q. So let's see if n1 is factorable. Let's plug into factor_db, and then let's see. Yes, n1 is factorable, but we also want to get the values of p and q. So to do that, we have this. We have one of the divisors is q, and then we also need to find another. Maybe we can use GCD and find the find q using GCD and find the greatest common divisor, and another number that has the divisor of q is the value of n1. So the value of n1 also because p times q is n1, so q must be a divisor in n1, and n2 plus n1 times elusive. So let's start writing our script here. So GCD, so the value of q will be the n equals this, and then let's just say this is x, and then q will be equal to GCD, the value of n and x. So, and then p will be equals to let's test if this works or not. Print q. So it prints q, and then let's divide n by q. And this seems like and then let's see if p times q is n. So let's test this out. So right there, yep, it is n. So we know that that is p and q, and we have n. So we will also plug in the other values, n, e. So e is now 65537, and c will be equal to the value of this. So we have NEC, P, and Q, and then X, which is just N2 plus N1 times elusive, also known as elusive times P plus R times Q. So now we will just have to work on decrypting the RSA. So let's find the inverse function. Alright, so, so we need to find the value of phi is equal to p minus 1 times q minus 1. D will be the inverse, so let's rename this function to inverse, and then inverse of e and phi. M will be c to the power of d modulus n, and then we can convert m to hex and then decrypt the hex. Let's run it to see if this even works or not. So, yeah. Oops. Okay, so we finally got our flag here, and we can now just submit it. Okay, so we've just